Hi, this is a chapter about collision and how to solve the collision problems with momentum and impulse. Collision means a new type of motion. So for example, when Kelvin is hit by a snowball, the way we describe this motion includes the mass of two objects, initial velocity, final velocity, force, and time. So for example, a tennis ball hits the wall at 5 meters per second and rebound with 4 meters per second. We want to pay attention that the rebound velocity is negative. We introduced two new concepts. Momentum by definition equals to mass multiplied by the velocity of an object. And impulse, by definition, is the force in between two objects during a collision multiplied by the time, which is the duration of the collision. They both have the same units. So kilogram meters per second equals to Newton times second. So for example, a 100-gram tennis ball hits the practice ball at 5 meters per second and rebound at 4 meters per second. What's the change of momentum? So applying the definition of momentum, we can calculate that the change of momentum is this, and that's negative, meaning the direction is opposite the initial direction. That means the momentum decreased and changed direction. Okay, another thing we look at is how force change motion. We've learned Newton's law, work energy theorem, and now introduce what's called the impulse momentum theory. These are three different ways to look at how force change motion. For example, a 100-gram tennis ball hits the practice ball at 5 meters per second and bounces back after 0.03 seconds. That's very short time because it's a collision. Rebound at 4 meters per second. What's the average force during a collision? So we're going to analyze this motion. In this case, the two objects are tennis racket and tennis ball, but we are only interested in the tennis ball. So we analyze the motion of the tennis ball. The change of momentum can be calculated, and if we apply the impulse momentum theory, we can calculate the average force. The average force is 30 newtons. 30 newtons negative. That means the force actually hits the ball, and it's opposite the direction of the initial velocity at which the ball hits the wall. Okay, so that is impulse and momentum. The second law we introduced is called the conservation of momentum. So for collisions, the total momentum of the two objects is the same before and after the collision. For example, this is the experiment. We'll look at how the momentum is conserved. There's a red car and a yellow car. If we just assume they have different mass, we're just making up two numbers, 100 grams and 50 grams. Which law can be applied here? Well, if the two cars are colliding with each other, then we apply conservation of momentum. That's the answer to this question. In summary, we introduced a new type of motion, that's collision. Collision involves two objects. And we introduced two new concepts, momentum and impulse. And we introduced two laws, impulse momentum theorem and conservation of momentum.